Welcome to today's deep dive. I am thrilled you are joining us. What if I told you that one of the most famous concepts in modern physics, the mind-bending idea that physical objects literally shrink as they approach the speed of light, what if that might actually just be a math error?
I mean, it is a massive claim.
Right, like a typo in the universe's checkbook that just, never got corrected.
Yeah, and it strikes at the very foundation of how we understand space, time, and, well, reality itself.
Exactly. And if you're listening today, you are here for exactly this kind of aha moment. You want to unpack these big, complex ideas without getting completely buried under a mountain of academic jargon.
Which is easy to do with physics.
Oh, absolutely. So our mission for you today is to explore a really fascinating set of translated notes and AI-assisted analysis of a document titled MathJack. It's written by an author known as Zionod 2023, and it presents a radically different perspective on Einstein's relativity and this thing called Lorentz contraction.
The notes really present a profound clash of worldviews. On one side, you have the author critiquing the traditional physics industry, arguing that for the past century, it's been trapped in these abstract, highly complex mathematical models of space.
Just geometric space alone, right?
Right. And on the other side, the sources introduce what the author calls the Zionod chat theory.
And the defining feature of the Zionod chat theory, according to the document anyway, is that it completely rejects that abstract math. It argues we have to return to pure Cartesian coordinate space.
Yes, and specifically, we have to center our entire understanding around a local camera eye.
A camera eye. I love that term.
It's very descriptive. It means an actual observer existing at a single physical local point in that Cartesian space. And we have to deal with the real information gathering process.
Because in the real world, there's a physical delay of information traveling through an absolute electromagnetic field, right? It takes time for the camera eye to see things.
Exactly. That contrast is basically the beating heart of today's deep dive. It's a shift away from thinking purely in terms of malleable geometric space and moving toward analyzing the actual information delay for an observer.
So to wrap our heads around this new theory, we first need to understand the historical mistake the sources claim the physics industry made in the first place.
Which takes us back to the late 19th century.
Right, to a physicist named Hendrik Antoon Lorentz. Okay, let's unpack this with an analogy. Think about balancing your monthly budget. Imagine you make a math error early on in your ledger.
Which happens to the best of us.
Oh, constantly. So you get to the end of the month, and your numbers are short by, say, $50 compared to your bank statement.
Okay.
Instead of going back through every single line item to find the actual mistake, you just add a random dummy fee, a miscellaneous $50 charge at the bottom, so the final numbers balance perfectly.
That's a great way to put it. And based on these notes, the author claims this is precisely what Lorentz did with the laws of physics.
Just added a dummy fee to the universe.
Pretty much. To give some context, Lorentz was trying to make sense of the famous Michelson-Morley interferometer experiment. Back then, physicists believed space was filled with an invisible substance called the ether.
Right, the ether wind.
Yeah, and they expected to measure the Earth's speed as it pushed through this ether. But the experiment kept failing to detect any change in the speed of light, no matter which direction the Earth was moving.
Which created a huge crisis, right, because the results completely defied classical physics.
Completely.
They expected a headwind or a tailwind to change how fast the light appeared to move, but the light just stubbornly kept moving at the exact same speed.
Right. So Lorentz stepped in to save the math. He noticed the apparent speed of light behaving strangely, but according to the analysis in this MathJack document, Lorentz fundamentally messed up the prior calculation in geometric space.
He made an error in the foundational setup.
Exactly. He made a math error in his physical ledger. And to hide this error, to force the experimental results to balance with the classical math, the sources argue he invented a mathematical patch.
The fudge factor.
A literal fudge factor. And this patch is what standard physics now calls Lorentz contraction.
Let's define that for you listening, because it is honestly wild. Lorentz contraction is the accepted scientific idea that an object literally shortens in length the faster it moves.
That's what's taught in textbooks.
Right. So if a spaceship flies past you at near the speed of light, standard physics says that spaceship physically squishes in the direction it's traveling.
Which is the accepted reality today. But the core assertion from the Zionod 2023 document is that the traditional physics industry took this mere fudge factor, this miscellaneous charge Lorentz used, and codified it as absolute physical reality.
They assumed moving matter actually physically shrinks.
Yes.
But wait, if Lorentz contraction was just a mathematical band-aid, how did an entire generation of brilliant physicists, including Albert Einstein, how did they fail to notice it?
It's a fair question.
Why wouldn't they just go back, find the error, and redraw the map to reflect reality?
Well, the notes suggest it was because of sheer desperation to make the speed of light a constant. Einstein and his mathematician colleague Hermann Minkowski, they inherited this mathematical patch from Lorentz.
Okay.
And to make this shrinking space idea work mathematically without breaking everything else, they had to invent a completely new way of mapping the universe. They had to treat time as an imaginary axis within a complex space.
Complex space. Okay, that sounds incredibly intimidating. Break that down for us. What does complex space actually mean here?
Basically, it means they stopped doing math in a tangible, physical 3D room.
They left the real world.
Yeah. Instead of dealing with real physical distance, they built abstract mathematical models using things like concentric spheres or unit circles.
Can you give an example of how that works?
Sure. The sources give a really good illustration. Imagine light departing from a star deep in the past, say at a time of -100.
Okay, -100.
And it arrives at our eyes right now at time 0. In this complex space model, the physics industry mapped that journey not as a physical distance traveled through a real environment, but abstractly.
Abstractly how?
As a geometric arc, like a semicircle drawn on a theoretical graph.
Hold on, I have to push back on this. Are you telling me that standard space-time diagrams, like the fundamental models taught in university physics classes, they completely abstract away the observer?
Yes.
How can a model of the physical universe just ignore the person actually looking at it?
Well, the author of the MathJack document asks that exact same question. This is the central crux of the Zion-Adchat critique.
It just seems so counterintuitive.
It is.
Yeah.
By thinking only in this abstract geometric space, the physics industry created a model that completely ignores the camera eye.
The camera eye. That is such a brilliant term. It instantly grounds the concept for me.
It really does.
When the author says camera eye, they mean the actual observer, a real local point existing in Cartesian coordinate space.
Exactly.
And for you listening, when we say Cartesian coordinate space, just think of the standard 3D grid you might have learned about in school. Imagine a physical room with a definitive up, down, left, and right.
Where distances are measured in real physical inches and miles.
Not imaginary math arcs.
Right. But the traditional physics model abandons that room entirely. And by abandoning that room, the sources argue, they completely ignored the fundamental reality of the information gathering process.
Because they ignored information transmission delay.
Precisely. In a physical Cartesian space, it actually takes physical time for light to cross a distance and hit that camera eye.
Right. Light has a speed limit.
Yeah. By swapping that physical delay out for an imaginary time axis, standard physics essentially abstracted the observer right out of the universe.
Okay, let's make this tangible, because the sources provide a really specific mathematical breakdown of a thought experiment. It proves exactly how this trick works.
Yes, the interferometer experiment.
Right. And to visualize this, I want you to imagine something you have probably experienced: walking on an airport's moving walkway.
That's a fantastic real-world parallel.
If you step onto a moving walkway and walk forward, you feel like an Olympian. You are just flying. Your apparent speed is your walking speed combined with the walkway speed. You have this massive tailwind.
Makes sense.
But if you drop your phone, turn around, and try to walk backward against the direction the walkway is moving...
You're barely making any progress at all.
Exactly. You are fighting a severe headwind, and your apparent speed drops drastically.
So let's apply that walkway logic to the specific numbers from the source material to see how this works with light.
Okay, lay the numbers on us.
Imagine an interferometer apparatus, basically a device that splits a single beam of light, sends down two different physical arms, bounces the light off mirrors at the ends, and sends it back to the center to be measured.
Got it.
Imagine this entire apparatus is moving along the x-axis, so a straight horizontal line at a speed of 0.6 c.
Okay, so 0.6 c. That is 60% the speed of light. Our airport walkway is moving incredibly fast.
Very fast. And let's establish the size. The apparatus has a total arm length of 20 units. So from the center half mirror where the light splits to the outer reflection mirror, the radius is 10 units.
Radius of 10. Okay, I'm picturing it.
Now, according to the Zion-Adchat theory, we must calculate the apparent speeds of the light strictly from the local perspective of our camera eye.
Which is sitting right there at the center of the apparatus.
Exactly, dealing with the actual information delay based on its own velocity.
So let's calculate the tailwind scenario first. The light leaves the center mirror and chases the front reflection mirror.
Right.
But because the whole apparatus is moving at 0.6 c, that front mirror is running away. So the apparent speed of the light catching that fleeing mirror is the speed of light, which is 1.0 c, minus the speed of the mirror, 0.6 c.
Leaving an apparent speed of only 0.4 c.
So it's slow.
Very slow. The light is severely struggling to catch up because its target is constantly moving away from it in the Cartesian space. It is going to take a very long time to finally hit that front mirror.
I can almost feel that delay. It's like chasing someone down a train aisle while the train is pulling out of the station.
Exactly. Now, what about the headwind?
Okay, so the light finally hits that front mirror and bounces back toward the center. But remember, the center mirror is rushing forward to meet the returning light at 0.6 c.
Right, they are running toward each other.
So the apparent speed of that return trip is 1.0 c plus 0.6 c.
Giving us a staggering 1.6 c apparent speed. The light arrives incredibly quickly.
So here's the massive conflict, right? If we're doing physics in a real physical Cartesian space where we actually account for the camera eye and the physical delay of information.
The math is messy.
Yeah. The time it takes for light to go out and back along the x-axis, the direction of movement is entirely different from the time it takes light to travel out and back along the y-axis, which is perpendicular. The math dictates that the light literally cannot return to the center simultaneously on both axes.
But in the real world, when physicists run these actual experiments, the light does appear to return simultaneously. The apparatus doesn't just fall apart or show huge delays.
Right.
So the question the author poses is, how did Minkowski and standard physics resolve this math without acknowledging the very real physical delay of that 0.4 c tailwind?
How did they make the checkbook balance without admitting they were missing $50?
By taking the entire universe and tilting it.
Okay, I am going to need you to paint me a very clear picture here. What do you mean they tilted the universe?
This is the specific mathematical trick revealed in the Zion Onchat notes. To make that agonizingly slow tailwind of 0.4 c and the super-fast headwind of 1.6 c cancel each other out perfectly, Minkowski's spacetime diagram takes that physical 20-length x-axis arm of the apparatus.
The actual metal arm?
Yes, and it literally tilts it into the time axis on the graph.
Let me make sure I'm grasping this. If I'm looking at a standard graph where the horizontal line is physical space and the vertical line is time,
Right.
Minkowski took the line representing the physical metal apparatus and he rotated it diagonally.
Yes, exactly.
He slanted it so the front, the leading edge of the moving object, points upward into the future and the back edge points downward into the past.
That is exactly the mechanism. By slanting the physical object across the time dimension, the mathematical equations suddenly balance out.
Wow.
It perfectly absorbs and hides the delay of the tailwind and the speed of the headwind.
Wait, so if Lorentz contraction isn't a physical object literally squishing, what are physicists actually looking at when their equations say the object got shorter?
The author of the document defines the true nature of Lorentz contraction very bluntly. The notes argue it is nothing more than an orthogonal projection.
An orthogonal projection. Okay, let me see if I can translate that into something tangible.
Go for it.
Imagine taking a wooden yardstick, 36 inches long. You lay it perfectly flat on a table. If you measure it, it's 36 inches.
Makes sense.
Now, tilt one end of that stick upward at a 45-degree angle. Take a bright flashlight and shine it straight down from the ceiling so the tilted stick casts a shadow onto the flat table.
Okay, I'm visualizing it.
If you take a tape measure and measure that shadow on the table, the shadow is going to be significantly shorter than 36 inches.
That is a flawless analogy. In this scenario, the tilted stick is the physical apparatus, which standard physics tilted into the time axis on Minkowski's graph.
And the table.
The flat table represents the x-axis at a specific simultaneous moment, like time equals 0, and that shortened shadow cast onto the table. That shadow is the orthogonal projection.
So putting the pieces together from these notes, the author is claiming that for over 100 years, the entire physics industry mistook a mathematical shadow for physical reality.
That is the claim.
They looked at the geometric projection of a tilted line on a theoretical graph, and they told the world the actual physical matter shrinks when it moves.
According to the analysis of the Zion Onchat document, that is the monumental error of modern physics.
Incredible.
The author argues they confused a mathematical proxy, a clever trick used to balance the checkbook and hide the reality of information delay with a literal physical transformation of matter.
That is genuinely staggering to think about, but it leaves a massive vacuum, right?
It does.
If standard relativity is just an abstract mathematical shadow cast by ignoring the observer, what is the actual physical reality?
Which brings us to the ultimate alternative provided by the Zionachat theory.
Right. How does this theory say the universe actually functions if things aren't magically shrinking?
Well, the notes draw a very sharp contrast between the two worldviews. First, you have the traditional physics industry, a system the author provocatively calls Einstein's failure.
That is a bold title.
Very bold. This traditional system relies entirely on pure mathematical relative speeds. Think of the classic physics thought experiment. A train moving past a platform.
Sure.
Einstein argued there is no absolute background. All that matters is the math of how fast the train moves relative to the platform, or the platform relative to the train.
Right, relativity, the idea that everything is just moving relative to something else, and there is no grand static stage underneath it all.
But the Zionachat theory argues that by erasing the background medium, standard physics created unresolvable paradoxes.
Because it's not anchored to anything real.
Exactly. By removing the physical stage, the math lost its physical anchor. The Zionachat theory demands we return to the concept of absolute speed.
Absolute speed.
But not just speed in a vacuum, speed calculated relative to the global electromagnetic field coordinate system.
So, in this view, space isn't just empty nothingness where math happens. Light is a real physical wave, and it has to travel through a real physical medium, a global electromagnetic field.
Which brings us right back to the camera eye.
Okay.
The Zionachat theory solves the interferometer problem without resorting to magic shrinking shadows by simply accepting the reality of information delay within that field.
Okay, let's play that out.
If the camera eye of the apparatus is moving at 0.6 C through the absolute electromagnetic field, the light simply have to traverse a physically longer path to catch up to the moving mirrors.
Because the mirrors are physically swimming through the medium while the light is trying to reach them.
Right. Therefore, the light returns later. For example, if it takes exactly 10 seconds for the light to bounce back and forth when the apparatus is parked perfectly still at 0 speed in the field.
It will inherently take longer than 10 seconds when it is cruising at 0.6 C.
Exactly. The crucial revelation of the author's pure Cartesian math is this. The light returns later, but it returns simultaneously on both the x and y axes.
Wow. So no tilting the universe.
No tilting.
No shrinking matter. Just physical light taking a longer physical path through a tangible field and arriving slightly delayed at our local camera eye.
It replaces a deeply abstract, complex space with a grounded physical mechanism. It forces the math to respect the reality of the local observer's velocity within the electromagnetic field.
For you listening, you might be driving to work or folding laundry wondering, okay, this is some wild alternative physics, but why should I care if I'm not a cosmologist?
It's a valid question.
And I think the reason you should care is because this document, regardless of whether you agree with its radical physics, is a masterclass in critical thinking.
Absolutely.
It really highlights the fragility of complex systems. It shows us how easily a massive institution can lose touch with reality if it ignores the simple, grounded perspective of the camera eye.
Well said.
When we forget the actual observer, when we ignore the real-world delays and the absolute environments we actually live in, we start inventing wildly complex theories just to explain away our own foundational typos.
The author's critique serves as a really powerful reminder that sometimes the most confusing paradoxes do not require increasingly complex math to solve them.
They require us to step back and check our initial assumptions.
To ask ourselves if we are looking at the object itself, or simply a shadow it cast on the wall.
Let's retrace the steps of the journey we just took today. We started with the claim that Lorentz made a geometric mistake while trying to solve the Michelson-Morley crisis, patching his physics checkbook with a mathematical fudge factor.
Then we explored how Einstein and Minkowski inherited that patch.
Right, building a wildly abstract, complex space that completely ignored the camera eye and the physical delay of information.
We broke down the 0.6C thought experiment and saw the mathematical trick. To hide the massive delay of the tailwind, standard physics tilted the math into the time axis.
And that tilt revealed the author's ultimate claim that the famous contraction of space is nothing more than an orthogonal projection, a geometric shadow.
Which led us to the alternative Zionachat theory.
A demand to return to pure Cartesian coordinate space to calculate real physical delays based on our absolute speed through a global electromagnetic field, centered entirely on the local observer's information gathering process.
It is a massive structural paradigm shift.
It really is. And it leaves us with a final lingering thought to chew on. If the author of this document is right, if one of the most famous, universally accepted concepts in modern science, the idea that space itself shrinks, is actually just a mathematical shadow cast because we ignored our own camera eye, what else are we misinterpreting?
It makes you wonder.
Think about your own daily life, your own industry, your own area of expertise. What other established facts that we treat as absolute gospel are actually just abstract projections?
A lot of them, probably.
What if the impossible complexities we struggle with every day are just shadows, hiding a much simpler, grounded reality that we've simply forgotten how to see?
It is a question that makes you want to look a lot closer at the map.
And maybe double-check the map maker's math. Thanks for joining us on this deep dive. Keep questioning the shadows.